Showing you a map of isoquants, I mentioned that, well, if you are a producer, you want to produce as much as it is possible, right? If your task is to produce, and obviously the task of the producer is to produce, you want to produce as much as possible. But there are obviously some limitations. As a producer, you must realize that all resources of labor and capital, they don't come for free. You have to pay for them. So production is costly, and you can have some limitations when it comes to costs of your production. Hence the idea of isocost. The concept of isocost, again, iso, the same. It's a line of the same cost. Does it mean? Well, you could imagine it this way. You are granted some money for the production, a fixed money. And now this isocost shows you all possible combinations of labor and capital that you could employ with your money. So this is kind of the border of what you can employ to produce. So your isocost, as you can see, we call it TC here, like total cost, would be divided into two costs, the cost of labor and the cost of capital. The cost of labor being the price that you pay for each unit of labor times the number of units that you employ, whereas cost of capital would be the price for capital times the units, number of units of capital that you employ. So if you look at the graphics, this is isocost, and obviously you must have noticed that already. This is very similar to the budget constraint line for the consumer, right? This is analogical again, right? So this is a straight line. This isocost is just a straight line, and there are two important points here, the points of intersection with axis, and those 2 points show you how much of capital and how much of labor can you possibly employ. So this point on the vertical axis is based on the idea that you do not buy labor at all, you do not employ labor, and how much of capital can you employ with all your money that you have at your disposal, total cost, right? The point on the horizontal axis is about how much labor you could employ if you don't employ any capital. So these are your borders, okay? This is as much as you can do. And here again, we are interested in what happens if something changes to the costs. And we will also be interested in the slope of isocost. Possible shifts. What can change in isocost? First of all, there could be some changes in total cost. So imagine this is the situation when you are granted some additional money, or actually your total cost is reduced and you must do with less money with your production, right? So you can see here the increase in total cost, right? When you get additional money for your kind of producing budget, right? Then the whole isocost shifts outwards, meaning you have more money at your disposal. You can employ more capital, you can employ more labor. Your boundaries are greater, okay? So you've got kind of more freedom here, right? Then you can have some changes in the costs, like the price for labor or the price for capital. You've got price for labor here increasing on your right side here. And you can see if labor becomes more costly, then this isocost would shift with one end only, okay? So the available labor that you could employ is smaller now because it's more expensive, right? With the same money, you can employ less of labor, okay? It doesn't influence your capital. So that is what may actually change when it comes to isocost line. The slope. To find out something about the slope, we need to try and focus what would happen if we move from one point on the isocost line to the other one. So as you can see in my graph here, this is moving from point number 1, characterized or defined by K1, L1 resources. So this is the situation where we buy quite a lot of capital and a little bit of labor. Okay, and we move to another point. So with the same money, because total cost is constant, right? With the same money, now we want to get less capital, but of course more labor, right? So let's calculate money here. If we give up some capital, we could kind of save on our money, right? We won't spend that much money. So we will reduce our costs spent on capital, and that depends on how much of capital we give up, so delta K, right? And the price of capital, how expensive capital is. And when you multiply those two numbers, then you learn how much money you kind of save on decreasing capital. This is the money that you're going to spend on labor to keep total cost constant. So this delta K times PK, price for capital, must be equal to the change in labor times the price of labor, right? And the slope is change in capital to the change of labor, so that's delta K over delta L, and as you can see, this is minus price for labor divided by the price for capital. It's negative. You can see the slope here is negative, obviously, right? So the slope of isocost depends on the relation between prices for labor and for capital. Yet again, similarity to the idea of budget constraint line. Okay. Now let's have a look at both sides of the story. You remember our map of isoquants, so you can find them here in this slide, okay? Our isoquant Q1, Q2, Q3. We know Q3 the most attractive because you produce a lot there, right? Q1 the least attractive, the smallest production. And we've got our isocost here, the line that allows us to buy things like capital and labor, right? And we find the cheapest combination of resources here, and this cheapest combination of resources is analogy to the consumer equilibrium in the consumer choice theory, in fact. And so we find a possibility that with our money, limited money, limited to TC, to our isocost, with this money, we are able to reach the isoquant Q2, right? So with this money, this is the best isoquant we can get. So with this money, we have the biggest production. So if you have, with a given money, if you have the biggest production, then actually this is optimal situation, right? This is the cheapest combination of resources. Your production is then as cheap as it is possible. Okay, and this point of intersection showing you the cheapest combination of resources is the point for which the slope of the isoquant and the slope of the isocost are the same. So look at the first equation. This first equation shows you the slope of isoquant. The second one shows you the slope of isocost. So if you put them together, then we can, after one transformation, see that this cheapest combination of resources is given by the condition marginal product of labor divided by the price of labor should be equal to marginal product of capital divided by the price of capital. So if you are able to find this kind of combination that fulfills this condition, then here it is. This is your Holy Grail. This is the cheapest combination of resources.